So now we're actually going to go through and go through the getting started document and actually create the project right here. So the first thing you have to do is you have to create a new Vivaldo project. And so we say create project. We're going to call it, first of all, for some reason, it thinks that this shift register project's my root, but it's not. So we're going to call it demo proj. This is going to be an RTL project. So that's a typical VHDL project. And we are not going to add any sources or constraints right now. But what we are going to do now, this is as like I mentioned, this is important distinction. We're going to go through the bolt for a board. So we all know that the name is the Zybo 20 is the board. And we're going to hit finish. So this is going to give us our base project. This is pretty much how you start every typical project. There are some other projects that you can do. You know, pin, if you're actually creating a pin project. So like you're designing for a board or something. But this is your typical project. And I think we went through things, but now, like I said, we're going to actually show you how it's done. So the next thing is you have to create a block design. And this is your diagram. This is where you add your IP. So your IP is your intellectual property. That, as we saw, the first thing you want to add is your processing system. So we're going to go here, and we're going to go Zybo. Let's see if it. No, Zybo's the name of the ZYNQ. Okay, let's try this. Okay, did it not take the board? That thing is fishy. Let's look at my settings. Where are my settings at? Project settings, here we go. Nope, I want project settings. Project summary, properties. No, here we go. Maybe that's the problem. There, does it? Well, I still don't see the board. So let's see if I can find the project properties, which I thought were over here somewhere. hardware. So settings, here we go. Let's make sure that this is correct. Target device. Alright. Well, this isn't the right. Let me see something. I am going to make sure it's in the right place. No, it is. Let's make sure we get the right board. Name. Here, this should be the one. And that's better. Now let's try that again. You see we got board here. That was the problem. Here we go. Here's our processing system. So this is our AMD, our microprocessor. And we need to, first thing we're going to do is run block automation. So this is basically a tool that lets you do this stuff faster. I gotta make sure it's correct, that we have the correct settings. So, system, okay. So, we're making an external interface. And we're just keeping the defaults. Okay, so run block automation. Now we're going to add the IP, which is the GPIO. Double click here and enable dual channel. That's what I'm. Now I'm going to add another one, and this is not going to be dual channel. And now when I run automation, I'm going to say all automation, and this is buttons. This is going to be switches. And like I said, as you can see, this is how you connect these to the buttons and the switches that are on the board. Now this is where I messed up the other times. This needs to be LEDs. Okay. So we got everything now should be interconnected correctly. Let's make sure. And when we run regenerate layout, that's going to give us a nice little layout. And everything is, it may not look exactly. This is interesting. There's an interconnect that is not connected. well, let's validate. When I'm looking at the picture of this thing, doing things a little different. So let's validate our design. Validate design. And I'm getting some warnings. But I'm not. Well, this is interesting. I'm looking at the picture, and it doesn't look quite like it does, but you know what? We followed the steps, so I am going to guess that something, because the reset is, remember this was done on an earlier version, and let's save everything. And we're going to then, where is it? Create VHDL wrapper. Let Vivaldo manage it. I've never seen, so far I have not seen an example where, so you've got your wrapper and your design. So this is our, and again, like we pointed out last night, or in the previous video, this shows, this is how all these things in our design, how they kind of connects them to the code, to the, takes these objects that we created and lets it connect. That's what I call a wrapper. Wraps around the design so it can be built. And the next thing we're going to do is generate the Bitstream. So now all this is saying is since we haven't done anything else, it's gonna go ahead and do it. And this is going to take some time to generate, and then you can see how we did the SDK part, which should be relatively simple. Now I'm wondering, now we already demonstrated it, how to program the FPGA. So what we're going to do here is I'm going to see if I can run it on on the computer, just so we can verify. So this is going ahead and running. Now, all this, you can see also, this board specifies all the so if we want to hook something up to the Pmod, we can do that. And what happens here is, once this is generated and we create the, export the hardware, which is our next, our next step is export hardware. When we run the SDK, it's going to know to have the proper libraries. And this way we can actually write the code, for example, that reads in through the Pmod. Or in the case of this example, the code that's used is simply sets the direction and which is the inputs, and this is the output. This is the buttons. I mean, we're going to set the input, we're going to set the output. Sorry, the output is our LEDs, the input is our buttons and switches, and we'll look at that. And it is going to write this based on the switch data. It's going to write to the LEDs. Based on the button data, it's going to write output. So it's still going in synthesis, and as you can see, that's the idea. This is our output. These are our inputs here. But you see they're connecting to the objects on. So this input eventually finds its way to the processor. The processor does what it needs to do and sends it back out to the LEDs here. And as we mentioned before, this is basically our interconnect. So with this, the purpose of the AXI is to take our input here. This is our input GPIO, our buttons, our switches. Connect that to our processor. And the processor then will output, let's see, this will output to either our LEDs, or it'll output to the terminal. And we saw that that is what it's going to do. So this is a very simple program, but I think it covers the concepts of a number of important concepts here. It covers the concept of interconnecting with the various things on the boards. Now again, this doesn't have to be buttons and switches or LEDs. We could have, okay, it's done. We're just going to cancel that. And then the next thing we're going to do is export our hardware. Again, the purpose of this is so that when we go into the SDK, it knows what it has. It knows what libraries it needs. It knows what it's talking to. And that is what is going to run over here on our processing system. Again, this is a hardware processing system. If you have this board here, see if I can. This is the RDS7. Your RDS7 is going to, if you want to do, you can do something like this, but you will use a soft processor. What that means is instead of having a actual hard processor, an actual CPU, actual microprocessor, physical microprocessor. We use microblaze to create a microprocessor in the FPGA itself. So that's kind of interesting. Anyway, we're exported, and now we can launch our SDK. And we're just going to make that local. And it's getting the hardware, so it knows now, okay, I know what I have. This is our system HDF. So we're actually going to need another place we're going to need is when I have a video that I'm going to be putting out on Petalinux and setting that up. This HDF file is very important there, because that's how it knows what it has again. And you need this if you want to actually run, I believe, or package one of the steps. You need the hardware definition file, or it's not going to work. It'll complain. Anyway, so we have all our processing information. And what you need to do, now you're going to write the code that's going to run the processor. And that's the next step. So we say new application project. And we're going to do test proj. Doesn't really matter. It's going to be standalone. It's going to use our design and our processor. So what we're telling it here, of course, is use the Cortex processor, use our design object that we created. We're going to do it in C. We're going to create a new board support project, and now the next thing is we're going to do the hello world. And there are a number of other options you have, different guesses. There is an Echo CP. I don't know what all these are yet, but for our purposes, we're just going to do a hello world as our basis. Now, one thing you have to realize is we are going to go beyond. This is a very simple hello world. All this does is prints out hello world to the terminal. That's it. Now, what's nice kind of is that it creates these basic files which do the startup and clean up. Let's see. There we go. Okay. And you know what? We're not gonna. Let's shrink this down. I'm gonna move these windows around a little bit. And here is our SDK. Now we're looking here at init platform and cleanup platform. So this basic starts the UR here, and then it just you want outside the SDK. Okay. So we have this hello world, but we're going to replace it. As we saw, this example provides a more robust example. So what they tell you to do is just do a simple copy paste. So I am copying, and I went a little too far. Let's see if we got it. Yep. So I copy and go back. And now we're going to go back to the hello world. And we're going to highlight all this. And come on. And paste it. Now this is giving me, there we go. So we looked at this the other day. This is our little program. And we set, again, we're going to look, we set the buttons and the switches. We set the LEDs. And it goes in a loop, similar, as I said previously, kind of like Arduino, infinite while loop. Reads the switch data and writes it out to the LEDs. Then it reads the button data. And based on the information returned, it sends text to our terminal window. So that's, and you can see it does a little sleep there. And it also, this code, when you set up the terminal, the baud rate, the data rate parity. So let's save all that, and it's going to build it. So do not expect any issues. And you can see. So it's using because this is an ARM V7. We have our ELF, and now let's see if it lets me run it without being hooked. Okay, so now you can see how we built and created this project from scratch. The next step is what we was actually what we've already seen. The next step is running it and getting the output. When you press the buttons, you get text. When you move the switches, you get the LEDs. So let's see if there's anything else interesting we can do here. Run as start performance analysis. Can we do that without the... Okay. See if this will go. Yeah, so we're not going to be able to do that without being hooked up. But let's go back to normal. This is one thing I'm always doing when I'm using Eclipse. This is basically a version of Eclipse. Open perspective, other, and we want C++. And that should take us back to what we had. Now on the Vivaldo, one thing that's interesting is you can see different information about it, like utilization. I/O is 10%, timing, lookup tables 1%, lookup table RAM, I/O. This is the how much power the process is using, the clock, the static. I guess this is the static FPGA. 12 warnings, it looks like. So this is your basic project in using the Xilinx, the Digilent Zybo Z7 with the Xilinx chip on it, with the Xilinx zinc chip is what we have on it. And so there's a lot you can do with this thing. We're going to show some how you can actually run Linux on it. After all, you have a microprocessor. Microprocessors like to run operating systems. They like, just like the Raspberry Pi. So in essence, you can probably think of this thing as a Raspberry Pi plus this configurable in software bunch of components, building blocks, if you will. And if you even look at the thing, and you could see this on the Arty, it does have these pins that are the same types of pins you would find. Let's hold this so you can see it. Same types of pins, these pins here, that you would find on an Arduino. These are doing an experiment with outputting from there. But in addition, like we mentioned before, these here allow you to connect modules. So this is probably one of the most versatile pieces of hardware you're going to find, these types of boards. And the plan to do with this is the next step, the Petalinux. When you go through, there's a 50-page, a pretty long manual on getting this little guy. This is a camera. And I believe, if I'm right, this comes, I don't know if I want to take that out, but, because I don't want anything, but I don't know if you can tell, this is a little cable that goes on the back of the Zybo. And this is how you can do some cool experiments. So hopefully you've gotten some out of actually seeing me do this and create an actual program. So till next time.